This is to help you solve the first question. So hopefully after solving this question, you can solve the other questions that look similar to this. All right, so determine the frequency of a photon whose wavelength is this. First of all, whenever you see this little symbol here, that means that it's the exponent. So on forms, we can't do exponents. So that's 10 to the power of 2. Okay. Remember that the first step in solving these calculations is going to be to determine the formula. But we have 3 different formulas. In your notes, you guys should remember that we have the speed of light formula. So that's the speed of light is equal to wavelength times frequency. It's a little too bold. We also have the 2 energy formulas. So energy is equal to Planck's constant times frequency, and energy is equal to Planck's constant times the speed of light over wavelength. All right. So when you read the question, you want to ask yourself, is this mentioning anything about energy? So determine the frequency. So that's 1, frequency. That's what we're looking for. Given wavelength. Right? I see nothing about energy. So immediately we can cross both of these energy formulas off, and I know that we're going to be working with this formula. All right. Well, the speed of light is a constant. So this is in your notes. If you go back into that worksheet that I gave you guys, this worksheet says the speed of light is always going to be this number. I asked you guys to highlight it in class, so you should have highlighted this up here as well. So we're going to make sure that we take this number, and we're going to write that here. So the speed of light is 3.0 times 10 to the 8th. And the units for speed of light are meters. It's too bold. So meters divided by seconds. Right? We like to put everything in parentheses so we can remember that all of this is just one thing, C. The next part is the equal sign, so equals. The next part, this symbol is wavelength. So they gave me the wavelength. The wavelength is right here. So I'm just going to take this number and put it here. Wavelength, right? The next thing, this symbol is frequency. They're asking for frequency. So whenever they're asking for something and we don't know it, you just put the symbol. So frequency. So step 2, if you remember in your notes, step 2 was make sure that the units match. So after we figured out our formula, we have to ask ourselves, this is meters, this is nanometers. They have to be the same. So because this is nanometers, I need to convert this to meters. Now normally I would tell you guys to go to your King Henry chart, but you guys actually don't know nanometers. It's not on your chart, so I gave you a conversion factor. The conversion factor is 1 meter is equal to 10 to the 9th, so this is 10 raised to the power of 9 nanometers, right? So let's do our conversion. We'll do it down here. Let's do it in a different color. Let's do purple. All right, so first thing we have to do is to write down our given. So I'm going to take this number and just write it down. I know it's the given because this is the one I'm trying to convert. Right. Then we like to say that we can always put our given over 1 to remind ourselves it's a fraction. Step 2 is always going to be multiply fraction bar. Step 3 is going to be to take the units and put it into the correct space. Okay? So next thing, I'm trying to go to meters. By the way, I put nanometers at the bottom because nanometers was up here. In order for me to cancel it, I have to put it at the bottom. All right, the unit I was trying to get to is meters, so that goes at the top. Right? Then I have to ask myself what numbers to put. So here you can see that the 1 is with meters, so you just put the 1 with meters. And here you can see 10 to the 9th is with nanometers, so I'm going to make sure I put 10 to the power of 9 with nanometers. Right? Nanometers is in the top, nanometers is in the bottom, it cancels. So we're going to multiply our numerator straight across. So you end up with this number repeated because, again, this times 1 gives you the same thing, except for we no longer have nanometers. The nano got canceled, and so right now the only thing we have is just the meters. Just meters. Okay, see, meters. In the denominator, 1 times 10 to the 9th. So it's just 10 to the 9th. You're then going to put this into the calculator. When you put this in the calculator, please make sure you use parentheses. So there's two ways you can do this. If you remember the rules that we talked about in class, we said that, I think I have the, oh no I don't. We said that whenever you're dividing exponents, you just subtract them. So if this is 10, 2, so let me just show you down here. If this was 10 to the power of 2, so that's 10 to the power of 2. It's dividing, so exponents you subtract, and then 10 to the 9th. Right? So that's the same thing as saying 2 minus 9, and of course 2 minus 9 is negative 7. So that would be my new exponent. So the answer should be 4.00, and then the new exponent times 10 to the negative 7, and again my unit meters. To me, that's a lot easier than getting a calculator out. However, you can still get the calculator. So let's put this in and I'll show you how you end up getting the exact same number. So make sure you use parentheses. 4.00 times 10 raised to the power of 2, close parentheses, and then you're going to divide that by 10 to the 9th. So 10 raised to the power of 9. Right? So this E means times 10. So this is 4 times 10 to the negative 7. Exactly the same number we got. Okay? I have my new wavelength in the correct unit. I'm going to replace my old one. So before it was 10 to the 2nd nanometers. We now know it is 10 to the negative 7. So 10 to the negative 7, and the unit is now meters. Okay, so now I'm ready to just do my math. So I'm going to erase my conversion because I no longer need this. Right. So again, this was how you convert nanometers to meters. You're going to have to do this in future problems in this assignment, so make sure that you understand this. You can pause it if you need to. All right, so now I'm going to take this and just do the math. I'm trying to solve for frequency. This is what I want. So I need to get frequency alone. Right now, frequency is being multiplied by this number here. So if something is being multiplied, the way to get this by itself is to do the opposite, which is to divide. So you're going to divide by whatever it's being multiplied by. In our case, this number. So whatever you do to one side, you must also do to the other side. So we're also going to divide by this number. Another way you can think about it is you just brought this to the other side. Okay? Whenever you have something in the top and something in the bottom, so this is the same and the same, they cancel. So now what we're left with, let's go ahead and erase the second question here. Okay, what we're left with is frequency on this side, because these canceled, and this part right here is still on this side. Get rid of all that. All right. So now we have to do the division. Okay. So you just divide these two numbers. You can do that in your calculators. So just please make sure you use parentheses, like I said. All right. So that's going to be parentheses 3.0 times 10 to the power of 8. Divide by parentheses 4.00 times 10 to the power of negative 7. So again, this divide by this, and that's going to give you Oh, I pressed divide again, excuse me. 7.5 times 10 to the power of 14. Okay, and again, this equals frequency. But unless we have a unit, it's not correct. So remember, here is the unit on the top. So I'm going to just kind of pull the units out and do a little calculation on the side. Divided by, right? So divided by the unit at the bottom, which is meters. Just remember that whenever you're doing a complex fraction like this, so you have meters over seconds, fraction bar, so it's keep, change, flip. So we're going to keep the top, we're going to change division to multiplication, and we're going to flip the bottom. So instead of meters, it becomes 1 over meters. At this point, you can see meters is at the top, meters is at the bottom. What you're left with is 1 over seconds. So your unit is 1 over seconds. And that is the correct unit for frequency. So this would be the correct answer for number 1. Now, sig figs are important, so sometimes it's 3.00. So if you see 7.50, it's just because the speed of light, you can round it to different number of sig figs. So it's okay if you have 3 sig figs, not a big deal. The unit 1 over seconds, I hope you guys remember that's a special unit. It's called an inverse second, which also means the same thing as s to the power of -1. And because the scientist who found all of this out wanted to put his name on it, we also call that a hertz, which is represented Hz. So any one of these is a correct unit for frequency. So you're going to see that hertz is the unit that they put. That's correct because it means exactly the same thing. Hope that helped.